components of a chiller, and you will see the role of each part. I will also elaborate that on the pH diagram of the refrigeration cycle. I am going to start with the most important component, which is the compressor. Here I have a model for a water-cooled chiller. The compressor is the prime mover. It creates a pressure difference to move the refrigerant around the system. It is always located between the evaporator and the condenser. Here is the electric motor driving the compressor. You can see here a dismantled centrifugal compressor, showing the main parts of it like the stator and rotor of the motor, the shaft connecting the rotor with the impeller, and the necessary bearings. So, our compressor here is of centrifugal type. There are different types of compressors like screw, scroll and reciprocating compressors. For larger capacities like 300 tons of refrigeration or more, the centrifugal compressors are selected. The compressor work is elaborated on the chart from points 1 to 2. The refrigerant enters the compressor in gas state at low temperature, low pressure, and it exits the compressor to the condenser at high pressure, high temperature. Refrigerant gas enters the condenser at point 2 and exits the condenser at point 3. What happens inside the condenser? We will see now. The purpose of the condenser is to remove heat from the refrigerant which was built up in the evaporator. There are two main types of condensers: air-cooled as in the case of air-cooled chillers and split systems, and water-cooled condensers as in our case in the water-cooled chillers. Hot water leaves the condenser and enters the cooling tower. And due to the evaporation process taking place in the cooling tower, the water leaves cooling tower and enters the condenser at a lower temperature. The cycle then repeats itself. It is important to know that the refrigerant and the water do not mix together, they are kept separated by the pipe wall. This is a shell and tube section of the condenser where the water flows inside the tubes and the refrigerant flows on the outside. However, in the case of air-cooled chillers, there is no cooling towers, but instead air is blown across the exposed condenser pipes to remove heat from the refrigerant flowing inside the condenser tubes. The refrigerant now exits the condenser at point 3 and enters the expansion valve. The expansion valve is located between the condenser and the evaporator. Its purpose is to expand the refrigerant, reducing its pressure and increase its volume, which will allow it to pick up the unweighted heat in the evaporator. The expansion valve is elaborated on the chart from points 3 to 4. At point 3 the refrigerant is at high temperature, high pressure. It enters the evaporator at point 4 at low temperature, low pressure. Here we have the evaporator. It is located between the expansion valve and the compressor. Its purpose is to collect the unwanted heat from the water coming from the buildings. The return from the buildings enter the evaporator at around 14 degrees Celsius, where it gives its heat to the refrigerant, and then exits the evaporator at around 4 degrees Celsius, which is adequate